Okay, so hello everyone. Today I will be showing you the demo of this project, which is a GUI-based training for Few Shot Classification Model. So this is basically dependent on Few Shot classification, which derives itself from prototypical networks, and for in my case, in my coding, it will be based on ResNet network, which acts as the backbone for this one. So to run this program, let's first clone this repo. So copy https. Yes. So in your required directory, open the terminal and then do git clone and then paste the link. So this should clone the whole repository. Let's just wait for a sec. So it is cloned. Let's go into the folder now. So as you can see, this folder basically has images, which is for the repository, then the omnium dataset, and then the train folder, which has a required dataset, and then the readme license requirements file, and then the main code file. So in this video I have not gone through the code, so let's see how to run this program. So to run this program, I suggest for any ML model, I suggest you to have a virtual environment for Python. So I have already set it up. To set up a Python virtual environment, you can just Python -m and then the location of the virtual environment you want to place it at. So let's just use that like VNV for Python. So yeah. So my Python common virtual environment has been activated. So first thing you want to do is install the requirements. So for that we will do the command pip3 install. So I think I must increase the font size. Yeah, pip3 install clear. So pip3 install -r requirements.txt. So this is a file which has all the requirements. So we will just do that and let it do its stuff. Once it's done, we can now run the program. To run the program, we will just do a Streamlit run and then a train.py. So this will run the program, and let's see. So this is the program. So maybe I will just increase the font size. Yeah, so this is the program. So to train a Few Shot classification model, we will need to set some parameters here. First is the train to split ratio, which is the percentage in which you want to split your dataset. So I will do 75% for now. Then the unique number of classes in the dataset. So I will just show you the dataset. So this is the train folder. In this folder, I have two classes, Gujarati and then Bengali, and then I have the respective characters, and for each of those characters, I have 20 images. Similarly, for Gujarati also, for each of those characters, I have 20 images. So this is how my dataset looks like. If you want to set up your own custom dataset, you can make folders here, which will represent classes essentially, and then you need to put their images into those folders. That is also my train folder has two classes right now. I can take more classes from Omniglot dataset, but let's just leave it at 2 for now. So now the episodes in train set, it completely depends on your dataset and how complex your dataset is. So a good idea is to have it set anywhere between 200 to 600. That is a good value. So we'll just set it as 400. Next is episodes in test set. So test set episodes, they can vary from 10 to 100. So we will set it as 50 for now. Episodes is like the epoch in normal machine learning models. So next parameter is count number of images in each class of support set. So this represents, so there will be sets which will be given each of those episodes. So we want to tell the model how many images it should take in each of those sets. This also completely depends on the complexity of the dataset. So we will just take 7 for now, and then count of images in the query set. So query set is like completely dependent on the dataset complexity. Our dataset is not too complex, but it's not too less complex. because these are Bengali and Gujarati characters. They more or less like very similar, so we will just take these values. Next is the path of the dataset. So we can either put the relative path or the absolute path. So relative path for this will be train, because this train folder exists in the same directory, so this train will be fine for this. And then the image size for data augmentation. So this is important. If your image contains a lot of data, so it needs to be of high resolution. If your image does not contain a lot of data, it can be of less resolution. For example, let's just go to our dataset and then see one of those characters. These characters doesn't need to be like, these images does not need to be too large. These are 105 by 105 pixels. So you can set it to 100 by 100 pixels, so that will be fine. If you want to classify between more complex images like a dog and a cat, then you will need to go for little higher resolution, maybe like 150 or 200 by 200 pixels. That will be fine. So these are the parameters. So for the count of images, you can set it anywhere between 2 to 10. For the query set images, you can set it between maybe like 1 to 8 or anywhere any good value which you think is fine. You will actually learn this when you train the model. So when you train the model, you will basically, so when I click on this checkbox, it will start training the model. So let's train the model. So when it trains the model, it will basically give you the loss function basically plot versus the episode. So in each of those episodes, it will have some loss. So using that graph, you can determine whether the model is good or not. And then using the by evaluating the model on test set, also you will get to know how good is the model. It doesn't need to be overfit and it doesn't need to be underfit also. So let's just wait for it to for the model training. Okay, so the training is completed, and here the progress is also shown here. And then this is the loss function plot. So ideally this is not a very bad plot, but this is not good either, because as you can see, it's at many times the loss goes to 0. That it is like almost reaching the overfitting thing. So since the training is complete, we can uncheck this button and then let it reload. So once we have trained the model, we have these two buttons to evaluate the model on a test set or evaluate the model on a single image input. So let's evaluate the model on our test set. So let it do, we will wait. So as you can see, the model has an accuracy of 93.4% on a test set, which is fairly a very good accuracy. So we can now uncheck this button, and then we can just evaluate a model on a single image input. So by single image input, it means like we are actually predicting what the output should be for any given image. So we will do that from our dataset itself. So let's set this image only. We will just put it here and see the output. So it says class 0, so that is the output. So class 0 here represents Gujarati probably. That is all for the demo. Thank you. You can now try to train your own Few Shot Classification models by using this GUI feature. Thank you.